Hello everyone and welcome. My name is Javiera San Martín Parra and this is my thesis project titled Characterization of Historical Tsunami Sources in the Maule Segment using the logic tree approach, geological observations and probabilistic analysis methods. To begin, it is essential to understand the importance of characterization of historical tsunami sources. And as this site from Bigny et al. Says, comparing the 2010 Maule megatrust earthquake with earlier events or historical events is important for seismic hazard assessment, but the lack of precise information about some past events requires caution. And we believe this is the most relevant, the need of precise information, because through the characterization of historical tsunami sources or just historical events, we can understand the long-term seismic cycle, and in consequence, we can improve the territorial planning in the sense of seismic hazards and risk assessment. So in this figure from recent Madariaga are presented some few megatrust earthquake events that we know from the past in this area, and also represents the rupture length of each event. As we can see, there are not so many and we don't know so much about them, but historical information can help us to achieve this work. So the events to characterize are presented in the right list. It can be noticed that, for instance, 1730 and 1960 events are not considered, because even when they had impact on the Maule segment, its epicenters belong to the Valparaíso and Valdivia segments respectively. The scientific questions or research questions that drive this work are: first, it is possible to perform a characterization of historical tsunami sources using a methodology based on logic tree approach, statistical analysis and geological observations? Second, from the models obtained, can be performed a comparative analysis between earthquakes focused on the study of possible patterns in the seismic cycle? The methodology can be summarized in three main stages, which are: first, source generation. This part is focused on obtaining all combination of source model with logic tree code implemented by Cifuentes and its slip distributions based on Okada. As the logic tree generates multiple fault solutions, a rigorous methodology must be followed to restrict and select only those models that meet the physical and observational constraints for each event. Then, the earthquake individual analysis. This part is mainly focused on the model's comparison with historical records and geological observations in details and selecting the most probable sources by using a probabilistic analysis based on the cumulative distribution functions. And finally, we have what we call an inter-event analysis based on grouping the different events according to their depth domain in order to perform a comparative analysis between earthquakes. Also to study the presence of supercycles in the segment and ancestors of large earthquakes. Dividing the discussion in the earthquake individual analysis and inter-event earthquake analysis, in the first one we expect to obtain realistic model with heterogeneous slip sources according to available observations. Characterizing historical events with heterogeneous models allow us to understand the behavior of possible future events. Then we expect to recognize maximum slip patch location for each event. In the same way, classifying the events according to depth domains allow to recognize the accumulation of energy in different portions of the Maule segment. For instance, we can see in the figure that the central south area of the segment has had the majority of the megatrust events, but in the northern portion there is only one, the 1928 event. And if we are capable of classifying the depth of this event, we could talk about projections such as: is there an accumulation of energy in the shallower or deeper northern area of the segment? Is this part more probable to produce a megatrust event in the future? Now, about the expected result for the inter-event earthquake analysis, we expect to recognize the accumulation of energy in shallower or deeper portions of the Maule megatrust. Also to test the capability of determining the recurrence interval of ruptures, and the segmentation process in shallower or deeper portions of the megatrophs, considering along strike and along deep directions. And finally, to correlate the heterogeneous rupture process with seismicity or coupled degree. Thank you.